So here we have this parabola. It looks like this. And you know it would cross at -2 and 2. So the largest area of the rectangle underneath or inscribed, so it doesn't go all the way to -2, it goes to something like here and here and here. So it doesn't go all the way to those x-intercepts. So let's talk about what the area, right, because that's what we're trying to find. So the area equation, as we find it, that will be what we'll want to take the derivative of and set equal to 0. So let's think about it. My graph isn't drawn to scale, but you know there would be an x value in both directions. So this, I'll just call it width, will be 2x. All right. So then the height of the rectangle will be this distance. And so the height of the rectangle is actually going to be the y value because it touches the function, right? So that would be 4 minus x squared. Okay, so the area equation would be 2x times 4 minus x squared. Again, let's multiply it out before I go take a derivative. So I get 2x cubed. Now let's take the derivative. So I get 8 minus 6x squared. I set this equal to 0 because that's how I find the critical numbers, right? So I get 8 equals 6x squared. 8 divided by 6 is x squared. Divide them both by 2, so I get 4/3 is x squared. And so I get plus or minus 2 over root 3 is the x value. Okay, so let's talk about what the answer to the question is. So dimensions of the rectangle. Okay, so the width, I know, is going to be 2 of those x values. And so I'm just going to use the positive, right? I'm going to use the positive x value. So that would be 2 times 2 over root 3. Okay, what would the height be? The height is going to be the y value, right? So the y value of you plugging this x value into here, so I'd get 4 minus, and then I just subtract off 4/3, right? This quantity squared. And so that gives us, I guess I didn't finish this, so I get 12 minus 4, so 8/3. So this is 4 root 3, and there would be 8/3. All right, so that's the volume, or that's the largest area rectangle that fits inscribed. All right, so now let's go to a little more challenging one where we're talking about cost of things, but this is kind of real world. All right, so we've got a box again with a rectangular bottom, and it's got a height of h. Okay, so now it says it has a volume of 50 cubic inches. Okay, so we know volume equation is x squared h, and that's equal to 50. Great. Okay, so they give us some costs, and we want the minimum cost. So we're going to make up a cost equation, whatever that is, and then we're going to take the derivative of the cost and set it equal to 0. Okay, so the cost is going to be for the surface area, right? Because they're talking about the amount of material. All right, so cost will be, and so the cost of the sides will be $3. Okay, so $3 times, what are the areas of the sides? Well, I have 4 sides of area XH, right? Plus, and the cost of the base is $5. So 5 times x squared. So I see that my cost equation has 2 variables, so I really want to get rid of this h because everything else is in x's. So I can take this and solve it for h. 50 divided by x squared. So cost is equal to 12x, 50 divided by x squared, plus 5x squared. And then I could multiply that together. So I get 600 over x plus 5x squared. Okay, so that's the cost equation. So let me make some room up here. So I want to take the derivative of that and set it equal to 0. Okay, so make sure that if you want to, you can rewrite this as 600 x to the negative 1 plus 5x squared. Oops, let's get rid of that. Okay, so let's take the derivative. So c prime would be negative 600 x to the negative 2 plus 10x. So I want to set that equal to 0. So absolutely take the time to write that as the negative exponent that it is. So negative x 600 over x squared plus 10x equals 0. So then let's move this 10x to the other side. So negative 600 over x squared is negative 10x. Okay, so then they're both positive, right? And if I multiply both sides by x squared, I get 600 is equal to 10x cubed. And then I'm going to divide through by 10, so I get 60. Then I'm going to take the cube root. So x is equal to 60 to the 1/3. Okay, great. I've got one of the dimensions, and then here's the equation for the other dimension. So I'm going to put the x as 60 over to the 1/3. So 60 to the 1/3, and squared gives me 60 to the 2/3. So there's the other dimension.